Welcome back to your local news station. I'm your host, Coleman Schaffner. Today we'll be covering a very interesting topic, waves. There have been many reports about waves, so we just have to talk about it for you. Also, this town is pretty lame and nothing happens. So, what is a wave? A wave is an oscillation accompanied by a transfer of energy traveling through a medium or space. And if you don't know what energy or medium is the ability to work in medium, and a medium is something a wave travels through. It could be a gas, liquid, or solid. A wave comes from any object that generates the initial energy of a wave. Now let's talk about the different parts of a wave. On screen, you can see a diagram of a wave. The top of a wave is the crest, and the bottom is the through. The wavelength is the distance between the identical parts of a wave. The amplitude is the maximum displacement from the rest position of a wave. It also shows the energy carried by a wave. You can't see it on a diagram, but frequency shows how often a vibration repeats itself in a given amount of time. It could also be described as the vibrations per second. Before we talk about the types of waves, we must talk about things to do with waves. A single disturbance of a wave is called a wave pulse. When multiple waves come together, that's what is called an interference. There are constructive and destructive interferences. Constructive interferences occur when two waves add together, resulting in larger amplitude. Destructive interferences occur when two waves cancel each other out, resulting in smaller amplitude. Constructive interferences create a point in a wave with maximum amplitude called an antidode. A resonance occurs when vibrations traveling through an object match the object's natural frequency. Waves have speed, and you can find the speed of a wave with a formula. That formula is speed equals wavelength times frequency. There are also formulas for wavelength and frequency. Those formulas are wavelength equals speed divided by frequency, and frequency equals speed over time. There's so many types of waves, which all differ in some way. The three main types of waves are longitudinal, transverse, and surface waves. With longitudinal waves, the motion of the medium is parallel in which the wave travels. The compression is the condensed region of the medium which a longitudinal wave travels through, and the rarefaction is the region in which the particles are more spread out in a longitudinal wave. With transverse waves, the particles vibrate perpendicular to the direction of the wave. And with surface waves, it is a combination between longitudinal and transverse waves. Different waves fall into these categories. These waves include electromagnetic, mechanical, sine, standing, bow, shock, microwaves, and sound waves. Electromagnetic waves are transverse waves that have no medium. Mechanical waves have to have a material medium. Sine waves have a special curve. Standing waves have a stationary pattern formed after two waves pass through each other in opposite directions. Destructive interferences create a stationary point of a standing wave, called a node. Bow waves have V shapes and travel at the same speed as the wave speed. Shock waves are three-dimensional waves in the shape of cones. Microwaves have the shortest wavelengths, but the highest frequencies out of all waves. Now we'll have a whole section all about sound waves. But what are they? Well, sound is a transfer of energy caused by a vibrating material as a longitudinal wave. A vibration is a wiggle in time with back and forth motion. Forced vibration is when something is made to vibrate. To hear sound, you need a source, a medium, and a receiver. The speed of sound depends on the elasticity, density, and temperature of the medium. You've probably heard of pitch, which is how high or low someone hears a sound. It can also be described as the frequency of a sound wave. Timbre is used to describe the quality of a sound. Noise doesn't have a pleasing timbre and also doesn't have an identical pitch. Wait, what is that? Okay, this just in. Musical instruments produce sound waves for the reasons we have just described. Here's a piano, a musical instrument. Music is a set of tones put together to make pleasing sounds to humans. The piano is creating sound waves because of the vibrations from the strings inside the piano. As you can hear, I'm starting to play louder right now. Loudness is how loud someone hears a sound, and it is measured in decibels. You can't do it on a piano, but there can be noises so high or so low, making it impossible for humans to hear. These instances are what we call ultrasounds and infrasounds. Ultrasounds are sound waves with frequencies too high for humans to hear, and infrasounds are sound waves with frequencies too low for humans to hear. Other terms to do with music are acoustics and beats. Acoustics describe how well a sound is heard in a particular place/room, and beats are the repeated change in loudness. We previously mentioned electromagnetic waves, which, if you forgot, are transverse waves with no medium. To go along with electromagnetic waves is the electromagnetic spectrum. The electromagnetic spectrum is the range of electromagnetic waves placed in order of increasing frequency. The electromagnetic spectrum is made up of radio waves, infrared waves, ultraviolet waves, X-rays, and gamma rays. Radio waves are electromagnetic waves that have the longest wavelengths and highest frequencies and can travel through a vacuum. Infrared waves have shorter wavelengths, yet higher frequencies compared to radio waves. Ultraviolet light has wavelengths that are too short to see on the electromagnetic spectrum. X-rays are electromagnetic waves with very short wavelengths. They are used to look at bones inside the body. Gamma rays have the shortest wavelengths and highest frequencies out of the whole electromagnetic spectrum. Visible light is the part of the electromagnetic spectrum that you can see. Moving on, we will begin to talk about light. Light is produced when atoms and electrons vibrate more than 1,000,000 times per second. A photon is a massless bundle of electromagnetic energy that we see as light. Transparent materials allow for light to travel through in a straight line. With opaque materials, light doesn't travel through it in a straight line. The light instead gets absorbed by the opaque material. There can be instances where light rays can't reach somewhere. A shadow is formed when light rays don't reach somewhere, but it is not always fully blocked. A penumbra is a partial shadow, and an umbra is a total shadow. Radiation is a bunch of energy moving around through space as an invisible wave. If it is ionizing radiation, there are higher energy levels, and if it's non-ionizing radiation, there are lower energy levels. Alpha particles are a fast-moving helium nucleus. Beta particles are fast-moving electrons. Fast-moving neutrons carry a photon. Gamma and X-rays are fast-moving energy. Now we will talk about reflection and refraction. A reflection is the bouncing of particles or waves. It strikes the boundary of two media. If something is totally reflected, everything is reflected. Nothing is transmitted. And if something is partially reflected, some is reflected and some is transmitted. The law of reflection states that the angle made by the incident ray in the normal, called the angle of incidence, is equal to the angle made by the reflected ray in the normal, called the angle of reflection. Mirrors are a very obvious example of a reflection, and there are lots of terms to do with mirrors. An object is where the light rays start, and an image is where the light rays appear to start. With a virtual image, light rays actually do not start there. With flat mirrors, the image is the same exact size, but left and right are reversed. With a convex mirror, the mirror curves outward, resulting in a smaller image. With concave mirrors, the mirror curves inward, resulting in a larger image. When light is incident on a rough surface and is reflected in multiple different directions, it is a diffuse reflection. A refraction occurs when a wave changes direction as it crosses the boundary between two media. An atmospheric refraction is the deviation of light from a straight line as it passes through the atmosphere. A dispersion is the separation of light into colors. It is arranged based on frequencies. Finally, we'll cover terms that don't really fit under one big category. Lenses are pieces of glass that are just the right shape to bend parallel rays of light and form an image. There are converging and diverging lenses. With converging lenses, there is a thicker middle, and with diverging lenses, there's a thick middle and thick ends. Huygens' principle shows that wavefronts are made up of smaller wavefronts. And finally, diffraction is a bending of a wave that isn't from a reflection or refraction. I hope you enjoyed this news report, and I also hope that you learned a lot from it. There are so many things to do with waves, and in my opinion, they are very interesting. I'm Colin Schaffner, and have a great rest of your evening.